So as we all know, on all of these conferences and events, people are always talking about LLMs. But what's important to us as developers, software engineers, architects, is how we actually build some stuff with this, because in the end, we need to build some products. So today I will be speaking about how to build your own custom copilots, because as we all know, even superheroes need sidekicks. So Marco already introduced me, so I won't speak too much on this slide. Just if you want more information about Microsoft Azure or anything AI related, follow me on LinkedIn. I post content often there, so you might find some of my posts very interesting. So let's go ahead and go through the table of contents and what actually I will be speaking about today. So first, we are going to have a short introduction about OpenAI and GPT models. Then I'm going to explain about the Azure OpenAI service and what it offers you as developers and how to utilize it in your applications. Then we are going to see a Copilot architecture and analyze all of the components and see how they play an important role in the experiences you are having with these types of applications. Then I'm going to deep dive into the semantic kernel, and we will see how it actually enables us to build our own custom copilots. Then I'm going to demo a simple custom copilot I have made, and we will see how I'm utilizing semantic kernel to build these types of applications. And in the end, I will talk about how to architect these intelligence applications in the cloud. So as we all know, OpenAI is the company that actually developed and released ChatGPT, a tool that we all know and I think everybody uses daily. So these GPTs, or generative pre-trained transformers, are a family of neural network models that use the transformer architecture. And basically, they are powering generative AI applications such as ChatGPT, many of the Microsoft copilots, and maybe in the future, even your own custom copilots. What's important to note about these models is that they are trained on large amount of publicly available data. And this training takes lots of time and compute resources. And these models process the text using tokens, which are just a common sequence of characters found in the set of text. And these models actually learn to understand the statistical relationship between these tokens, and they are just great at producing the next probable token in that sequence of tokens. So if I now go ahead and switch over to the, let me just move this, tokenizer on the Azure OpenAI platform, we can see how actually it processes the text into tokens. So this will be a little bit hard for me, but let's try to copy this text and just paste it in the input here. So what we can see now is that this text is composed of 34 tokens. And what's important to know here is that not one word equals one token. So in our case, the word tokenized is broken down into 2 tokens. So basically, one word can be broken down into multiple tokens. And tokens are very important, and we will see why later, but just keep in mind that this is how your prompt is being processed. So now that we know what these models are, how can we actually go ahead and deploy these types of models to actually use in our application? Let me just switch back to the PowerPoint. Oh, I don't know what's happening, sorry. So this is where Azure OpenAI can help us. So Azure OpenAI provides REST API access to OpenAI powerful large language models, including GPT-4o, GPT-4o Mini, maybe GPT 3.5 Turbo, and many embedding models as well. What's great about these models is that they can be easily adapted into tasks that you need, like content generation, maybe image understanding, natural language to code translations, and many more. But maybe the most important thing about Azure OpenAI is that customers get the security capabilities of Microsoft Azure as the cloud platform, which means that it offers you private networking, regional availability, responsible AI content filtering, and many others, which we will take a look at a little bit later. So now let's take a look at how we can actually create these types of resources, how we can deploy a model in there, and how to actually use these types of models in our applications. So now I'm going to go ahead and switch to the Azure portal here. And you can see I have this Azure OpenAI service here. And I have already created 3 of these services that I use. If you want to create a new one, you can go ahead and click on the Create button. I can try, but I'm not sure how. And you will be prompted to enter some basics for your service, like the subscription, the resource group, the region, name, and pricing tier. So what's important about the pricing is if I switch to the Microsoft documentation, we can see that it offers 3 pricing for us to choose from. One is the standard or pay-as-you-go pricing, which is where you are paying for the input and output tokens. And basically, this is the most common pricing that you will use. The second one is provisioned, so allocated throughput, where you buy PTUs, but basically this will be used when you know what performance that you expect from this service. If you buy more PTUs than needed, you will be just wasting money, so you'll be using this maybe at a later stage when you understand your applications. And the third one is the batch API, which can be used if you don't need to return the completions immediately and can wait 24 hours for that. And that's basically on a discount based on the global standard pricing. And if I scroll down here, I won't go into too much details on this. You can see for the different models, different pricing per 1 million tokens. And basically, you pay for the input, output tokens as well. So basically, that's why it's important for us to think about how to actually control these tokens consumptions as well. So we saw how to create this resource. So let me now go ahead and go back to the portal here and open one of my existing resources here. And let's see what actually it offers us through this service. So on the left side, you can see a bunch of options that we can actually use. The first is the playgrounds, where you can actually go ahead and test these models that you deploy. There is also a fine-tuning options, which I will just talk briefly about. But what's important for us is this deployment section here. So if I click on the deployments, what you will see, I have already deployed 2 models that I'm using in my applications. One is the GPT-4o model, and one is the ADA text embedding model. And how you can actually deploy new models is just from this deploy model. You can go ahead and deploy a base model. Just choose the model you want to use, and then click on confirm. You will be prompted to enter the deployment name and the deployment type. What's important here is that the deployment name is the one that you will be using in your applications to actually go ahead and use this service, along with the endpoint and the subscription key. It's preferred to use managed identities, so you should be aiming to use that instead of the keys. Note that when we deploy these types of models, treat them as read-only. So basically, you cannot add data to your models. As I said, you can go ahead and fine-tune the models, which you can add your data to the models, but that's not recommended, especially in the case where you have lots of constantly changing data. And in many of your applications, you will have just that. So you will be deploying these instances. So now we need to think about how to actually use our own data with these types of models, because as I said, these are trained on publicly available data, so they have no knowledge on your private data. So now that we know how to actually deploy these types of models and what we need to consume this in our applications, before we start building something with these models, let's first see what a Copilot architecture looks like. Let me ask, does anybody know what is a Copilot? Nobody? Maybe what they do? Helps you, yes? Assistant, okay. So let's see. So on this slide here, I have a Microsoft Copilot for Microsoft 365 architecture. And what we can note from the start is this is not your standard application architecture that you're used to building. So let's analyze the steps that are happening behind the scenes, and let's see what we need to actually pay attention to when building these types of applications. So the first step here is that the users, so you will send the prompt to the Copilot or the orchestrator. But what's important to note is the Copilot will not immediately send that prompt to the large language models. What it instead can do is basically access different types of services so any service that you have. In this case, it accesses Microsoft Graph, maybe calling the web. So to actually get grounding data that it will pass to the model with your prompt. What it means is that the Copilot will create this modified prompt or meta prompt and then send that prompt along with any grounding data it has to the large language model that you deploy. What's important to note is that the prompts, responses, and grounding data are not used to train these models. And that's very huge when we think about security of your private data in these types of applications. So then, the large language model will return the response back to the Copilot, which again does not immediately need to return the response back to the user. What it instead can do is access different types of services again, in this case Microsoft Graph for compliance and Microsoft Purview for any content filtering or other types you need to do checks. And then you will just return the prompt back to the user. So now we saw that here there are different components in play. So we said the concept of accessing services using plugins. We said that this is a Microsoft 365 Copilot, so we know there are multiple Copilots available. And we also see that maybe the whole process might take multiple steps to get the response back to you. So it might not need one task, but multiple tasks. So how are we able to actually do all of this in our applications? This is where we can use semantic kernel. So think of semantic kernel as an SDK for working with these large language models. And basically what's important to note here is, if you remember anything from today, from this presentation, it should be this slide. The Copilot will be made of 3 building blocks that will work together to complete tasks for you. And those are the plugins, the planners, and the personas. So because I said these are very important, let's go ahead and take a look at each of these separately and see what role they play in your overall Copilot architecture and solution. So first are the plugins. So the plugins are nothing more than giving your agent skills. What this means is that you can go ahead and give your Copilot skills via code. What this means is that what you can write code for, you can go ahead and expose it as plugins. You can go ahead and write plugins to send emails, to retrieve some stuff from the database, so perform some reg. Maybe save and read memories from previous conversations. So whatever you can expose as code, you can create a plugin. And basically, there are 2 ways of importing plugins into your kernel. One is the native code, which we will see in this presentation, and one more is through an open API specification. And when we think about this, we can see how powerful this can actually be, and it might change your way of actually designing your APIs. So on the next slide, I have an image code of a plugin that we use in our kernel. So this is nothing more than just a simple C# code that every developer writes. But what's important is the kernel function attribute, where you specify the name of the plugin, and the description, where we actually describe what this plugin does. And basically, this description will be used by the model to determine if it actually needs to call this plugin or not. So basically, the better descriptions you give, the better the model will be able to understand if this should be called. And the implementation for this is nothing more than just copy-paste C# code for writing email to a list of recipients. And this is great. We can see how easy it is to actually start giving our agent skills to be actually do stuff for us. But when we think about some tasks, even us as humans are doing, this task might require multiple steps. So for example, let's take baking a cake. So you might need to go ahead first and buy some ingredients for the cake, then prepare this, maybe bake the cake, and in the end, of course, eat the cake. So maybe the Copilot would actually need to take multiple steps to accomplish some tasks. And this is where the planners can help us. So planners are completing multi-step tasks. What this means is that to use the plugins and to wire them up into multiple steps with other plugins, the Copilot would need to generate some type of plan. And this planning comes from the built-in capability of the large language models to determine how to iteratively complete a task. What it means is that using semantic kernel with planners is nothing more than just invoking the chat completion service with the auto function calling enabled. So on this next slide, I have an example of how you can actually set up planner capability in your kernel. This code here that you can't see is from the newer versions of the NuGet package, but this does the same as this. So basically, I'm using this in my example. I just create this OpenAI prompt execution settings with the tool call behavior of out-invoke kernel functions. And then I just pass these settings to the chat completion service, and that's it. Now we can use planning in your semantic kernel. So one last thing that I said is that based on which application your Copilot is part of, so which domain or context, it might actually have different personas. So basically, you might have a project manager agent, copywriter, designer, or anything you want. And you can accomplish this using personas. So persona is nothing more than giving your Copilot a job description. And it's just a set of instructions that you provide to your AI to basically help it perform the role you want them to play more efficiently. You can instruct the AI to be polite, maybe to ask for clarifying questions, maybe ask for help, even escalate to a human if it's unable to complete some task. And how you define a persona is nothing more than just text that you send as the system message along with the user message that the user inputs. And then you just pass the message to the chat completion service, and now your Copilot will also follow this persona that you defined here. So now that we saw all of these three components and how they actually work together in these Copilots, let's demonstrate my custom Copilot here and see how it utilizes all of these things. So first I'm going to start asking it some basic questions that it will use its pre-trained knowledge to answer. Then I'm going to head and ask some question that will actually go ahead and retrieve some data from my data and return a response to me. And in the end, I'm going to go ahead and ask it to complete some tasks for me and see how it's able to do that. So I'm going to switch back to the portal here and go back to my resources and open the UI. So basically, those of you who work with me know how much I love working on UIs. So basically, if someone wants to help me with the CSS, you can go ahead and do that. Let's go ahead and say hello to my Copilot here. So give it a couple of seconds to answer first, because my app service is using low pricing and it's sleeping currently, but it will go ahead and give a response back in a couple of seconds. So we see it said, "Good day, Master Bruce, how may I assist you today?" So immediately what you will notice is that my Copilot has a persona here, and I think everybody knows who this is. This is Alfred, Bruce Wayne's or Batman's butler. And now my Copilot will actually keep this persona throughout my conversation with him. So let's now ask it how many calories were in the cake we baked previously. I think I spelled it correctly. And you will see how actually fast these models are in generating the response back to me. And it says that anywhere from 250 to 400 calories. But we don't care because we love eating cakes, so we're going ahead and eat it anyway. And this is all fine, but we don't want just this. We want our Copilot to work with our own data, as we said. So before we start working with that and showing the example, let me just switch back to the portal here. Okay, I was here. And see what data I have actually that the Copilot will work with. So if I open my Cosmos database account and open my databases in here, you will see that I have a database with a user task container in which I have a bunch of tasks that I have created for me. Each of these tasks has the description and the is completed property as well. So pretty simple. We can see some of them are completed. Some of them are not. Basically, this is a new Batmobile that I need to buy. So let's go ahead and see if it can actually summarize the task I have. So what it will do is actually access my database, get these tasks that I have here, and generate a response based on that data that I have in there. And it will use plugins to do that. So we can see it was able to actually go ahead and get my tasks and say that there are some completed tasks, but also some pending tasks. And it says that it's advisable to prioritize purchasing a new car as it is more significant and complex task. So we can see that now we are actually working with my data, and basically the model or the Copilot is able to access my private data, even though we know the models were not trained on this data. But again, this is not enough. What we would want to do is actually make the Copilot do stuff for us. So as for any task management application, let's go ahead and ask if it's able to create a task for us. So I'm going to say here now to create a new task for me to buy some drinks, whatever. And let's end this. So now if we see what the response was, we can see that the task to buy some drink has been successfully created. And we can see if this is correct or not. If I just switch back to my Cosmos container and just refresh, we can see that I have actually a new task here that my Copilot actually created for me with the description and this completed set to false. And this is perfect. Now we have some advanced capabilities in our Copilots. But if we think about how many steps the Copilot needed to take to accomplish these two things that we asked, it was mostly one. For the task summarization, it just needed to actually get the task from my database. And for this, it just needed to call a plugin that will just create this task. But what if now I want it to close some task for me? If you think about the steps here, first it will need to go ahead and somehow find the ID of the task, because I don't know this, it's a GUID, I think nobody will know these IDs. And then basically call the appropriate plugin to close this task. So let's see now that, where is the task? Buy a new car. Let's go ahead and say, I finished buying a new car. And let's see what it does. So now, even though that I didn't specify anywhere in the prompt for it to actually close the task or complete the task, it understands what I want and basically says that the task of buying a new car has been successfully marked as completed. And we can see again if it's lying or not. If I just refresh this document here, we can see that it was actually able to get the appropriate ID and then close this task for me. And this is how easy it is to build these types of copilots. So I'm going to jump quickly in the code here. I'm not going to show too much just because we won't have time. Let me just try to open my Visual Studio here. So you can see here that I have a class defined in which I have defined my plugins. And this class is called tasks plugins. And in here I have my 3 plugins that my kernel actually utilizes, so my Copilot. And you can see these are just nothing more than C# functions that have the kernel function attribute and the description. But also I provide description to any input parameters I have, because it's better that way for it to actually know what we are expecting here. And if I open just a code for one of these, maybe it's incorrect, I don't know. This is just simple C# code I write to actually work with my Cosmos database. So that's it. So how you add these plugins to your kernel is that if I go to the program CS file, you can see that here I'm creating a new plugin collection and then just importing these plugins to that plugin collection and creating a new kernel from this with this plugin collection. And how I use this is if I open my chat service here, we can see that first I have this planning enabled with the code we saw previously, and my persona defined here as a system message. And in the end, I'm just passing all of these to the chat completion service that I have. And this is it. This is how simple it is to wire these things together using semantic kernel and to actually start building your own custom copilots. So let me ask you this. Who else, including me, is excited about all the new features that are coming in these models, generative AI applications, and everything else? Okay, we can see that there are many people excited about this, and that's good. But if we think about this, is it actually that good? If we take a look at the Gartner hype cycle here, we can see that everybody today is at this level here, the peak of inflated expectations. So what this means is that people think that these new technologies will actually solve all of their problems, but that's not the case. And they're just interested in all these new shiny features that are coming out. But after some time, products will start to fail, and people will start to realize that this technology will not solve all of our problems. And they will understand what problems it actually solves, but most importantly, how it integrates with their current networking, monitoring, identity solutions, so how it integrates with your current cloud architecture. So now I want to speak about how you architect these intelligence applications in the cloud. And as I said previously, when you use Azure OpenAI, you actually get the security capabilities of Microsoft Azure as the cloud platform. And maybe the most important of this is the private networking. What this means is that on your service, you can completely disable the public endpoint and create a private endpoint. So now all the traffic coming to your service will use the Azure private network. So nothing will go through the public internet. And that's huge when we think about architecting these types of application. And maybe the second most important thing is that you can actually go ahead and import your Azure OpenAI service as a REST API into Azure API management. And if I go back to the portal, we can see that I have done just that. So if I go back to my OpenAI service and check the networking section here, you can see that I have completely disabled the public access on my service. And what I have done is basically enabled a private endpoint for my service. One more thing to note is that if I open my API management instance and take a look at the networking section, if I can find it, we can see that I have deployed this as external. So basically it's publicly accessible, but it can also access services within virtual networks. You would actually prefer to use the internal deployment and put maybe an Azure front door in front of this, but for this example, this is completely fine. And now if I go ahead and take a look at the APIs that I have in this API management, you will see that I have my Azure OpenAI service imported as an API here. And you can see all the operations that I can access on that API that I can access now through my API management and through my code. And one more maybe important thing, if you look at here, is that I have some policies defined here that actually have the Azure OpenAI in their name. So when we think about API management as a service, we know that it offers us the concept of inbound and outbound policies. And what Microsoft have done is they have invested huge amounts of efforts into creating these types of policies that we can actually utilize in our intelligent applications. So I want to go through a couple of them and see why they're important and why you should think about using them when building these types of applications. So the first one is semantic caching. What this means is that when a prompt comes, so the request comes, and when a response is generated and sent back from the LLM, you can actually go ahead and cache that response. So next time a semantically similar request comes, you can actually go ahead and just return the cached response. So this is using vectors. So basically to go ahead and vectorize the request and response, and then use similarity to actually determine if this should be returned or not. Next most important policies are the emit token metrics and token rate limiting. So as I said, because we are paying for this token consumption, we might want to be able to actually keep track of the tokens that we use. And emit token metrics will actually go ahead and send logs to your application insights about token usage. A token rate limiting will give you the ability to rate limit based on token consumption. You can use the client IP address here or the subscription key in API management, not Azure subscription, to basically rate limit requests. One more important policy is smart load balancing. As with your backend systems, you might also need to think about load balancing between multiple instances here as well, and maybe instances in different regions. So for example, if one of your instances starts returning 4 to 9 or too many requests, you might load balance requests to different instances. Message storing is another important one, where you can send message details to an Azure Event Hub, and then maybe save them to a Cosmos database or process them using Azure Stream Analytics, or whatever you need to actually get some more insights on that. Last two are content filtering and prompt shielding. Content filtering helps you actually filter out content that's maybe offensive or sexual or risky content before sending that to the large language model. And prompt shielding provides you with shields from the most common prompt attacks that are out there. So now we spoke about different things, from actually building these types of applications to architecting these types of applications. So maybe a question that all of you might have is, so how will my end architecture look like? And basically this is how it will look like. So this is the AI Hub Gateway Landing Zone architecture, and I think Microsoft are working on a second version now. And if we actually observe the components here, we can see that we have our API management as the single entry point into our intelligent applications. And all the traffic coming from the public internet is actually going through this DMZ network appliances zone, where you have maybe an Azure firewall or a front door deployed. And then after that, all the traffic is private. So basically, it will use private endpoints to actually communicate with the different parts of your architecture, like the backend systems, OpenAI services, maybe some other AI ML services, the usage metrics hub, and the performance monitoring hub. One more important thing in this architecture is that we see this concept of managed identities. So what this gives us is basically we can access these other services without needing to store any credentials. And we as developers and architects don't want credentials in our code. So basically we can utilize managed identities to actually access these other services. So one last thing I want to say is give an explanation on the question, will AI replace humans? No, but humans using AI will. So what I want to say with this is that, yes, Copilots are new and powerful tools that help you build new applications that were not possible today, help you in your career. But remember, they are here to assist, not to lead. You are still the pilots of your own applications, jobs, anything, and you are the ones steering towards your visions and goals. So I want to thank you very much for the attention, and if there are any questions, feel free to ask.
HTEC.